Welcome everyone to another episode of Behind the Curtain Wall. Can you believe it? It's been 6 months since we started this. We're on our sixth episode, and this one's a great one. We're talking about from the lab to the field, how principles shape a lasting career, and this one's a great episode to get some great insight, whether you're starting out or as a seasoned expert. We're going to be listening to some major pros in the industry. So, John, we're joined by John Medina, obviously, founder and principal architect at Miami Curtain Wall, and we're also joined by John Runkle, who is the senior vice president of Building and Science Resiliency in Pinchin. What's the official name for Pinchin? Is it just Pinchin?
Just Pinchin. Yep.
Pinchin. Okay, great. Well, welcome, John.
Thank you. Happy to be here.
Awesome. Tell us a little bit about what you do at Pinchin and how you came to meet John Medina.
Yeah. So there's kind of two ways to answer that question. So the first mission is to build a building science consultancy firm,
Sure,
specifically in the U.S. So Pinchin is dominant in Canada. They have about 1,000 folks there, and they do have a living, breathing, healthy building science group there, but really not a large presence in the States at all. And so my task is to do that, and that's across all the states. So I've got folks from currently from New York all the way out to L.A. But what I personally do on my day job is a little bit more of what we're going to talk about today, and that is, I'm a forensic engineer, and I work a lot, at least in the last 6 years, dealing with natural disasters and insurance claims, and inspecting, consulting on buildings from an engineering standpoint.
sure.
So we call it cause and origin in the business.
Oh, that's great. Yeah, and obviously we were talking earlier about these potential storm threats, so it's very fitting that we talk about that today. And how did you and John meet? We talked earlier, sometime last week, about meeting in the lab. So how did you two start working together or cross paths?
Well, it was really incredibly. I feel fortunate to have met John. So John is a peer, right? And so we are both in the same industry, and John had worked on a large claim, so he investigated the property. It was a window and door claim, and then I got brought in later as the appraiser. And so one of the things that you want to do is you want to bring the people that have knowledge of it, and obviously someone that inspected it years ago is going to be less prejudiced, right, than someone that is more recent. And so John, having already completed the inspection of the windows and doors, was essentially going to be a testifying expert um, on this appraisal file. And that was, yeah, I don't know, maybe about a year ago when we met. And it was just wonderful. It's always nice to work with colleagues. It's always nice to see kind of, you get you get to check kind of what your approach is. You get to learn some tricks from others like John that have been doing some great jobs. And so I feel grateful for the opportunity to have met him, and we've worked on a couple since. And most recently, John was recommended by, what you call it, like the other side, right? There's like a plaintiff and a defense in construction defect claim. There's an insured and an insuree, on the insurance side. And so John was actually recommended by the party on the other side, that we use as kind of an independent expert. And so he was working in the initial onset directly for the umpire. And so several touch points with John. I've enjoyed all of them, and I'm happy to be here today.
That's
Yeah,
great.
and I just wanted to add, to and that was a nice summary of how we met. But I think John, um, what I was impressed by was his uh, in the field knowledge of the tests that were being conducted in the field, and his desire to find the cause, source and pathway, as he was saying before, causation, the source and pathway of alleged leaks, and how he was intrigued by trying to arrive at conclusions that could be proven through the science of what we do. All right, and 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 that's a kind of a very difficult thing to do unless that's within your nature. And I was very impressed by John in that when we did testing and we looked at the results, we looked at them almost the exact same way. It's like, I want to see the proof and the path in which water took to say that that water was uncontrolled, and whether or not a storm could cause that leak or whether it was a maintenance issue. So as a and I think that in the field, I know that John comes from a testing laboratory background, as I do, and it was remarkable that we had that commonality. That it wasn't only about passing and failing water tests, but it was really truly about determining the cause, and then can you fix it? Is it
Right.
can you take care of it with a simple solution, or do we have to, like, as many people would think, um, take out the whole unit and start from scratch? And for the most part, that's kind of where things sort of fall into. It's like these two buckets of, can you fix it? Can you fix it simply, reasonably, that you really truly believe in the outcome, or can you, or do you have to like plug and play, right? Take the window out, put in a new window, and you're done. The notion of recycling, suitability, resiliency goes thrown out the window, and it's all about, hey, how much product can be sold, for a claim. And I think that John and I had that kind of commonality in that, look, there's a fair answer to most of these things, and then there are all the other ones.
Right, right. And this definitely speaks to, having that engineering background because really, there's a big difference between, like you were saying, and, really reverse engineering what the root cause of something is or what solutions can be provided. And that really speaks to, having maintaining these high principles, which we had talked about, I think about a week ago. So can you speak a little bit about how that really resonates with the roles that you both have in terms of testing and how that approach is really the way to go in terms of really having that integrity of testing in this industry.
Yeah, I mean, it's a great question, and to John's point, we both have that commonality of kind of growing up in a test lab, and you understand the importance of doing it the right way. In terms of there's requirements to be a certified lab and so forth. It's really easy to get out and spray water on something and get something to leak, but it doesn't always provide you meaningful data. And especially in the world that we're in, when we're dealing with existing buildings, there's not a lot of standard help to tell you how to do it. There's not a lot of specific guidance because each case is different, and so you lean on that foundation of kind of learning from the lab, and you get out there and in the simplest form, you try to have test one thing at a time as best you can. And you can't always do it, but as best you can. And you try to get to a result that is meaningful as best you can. And what I mean by meaningful is that the result actually speaks toward a leak path, not just a leak location, right? And that's again, it's very difficult to do. It's easy to say, well, the leak showed up here because I can see it. But if you
Right.
don't know where it started from on the outside all the way to where it showed up on the inside, then you don't know the leak path. That's the challenge.
And with what you're talking about, that one sort of theory of a cause and effect, all right, is all about that pathway of where the water entered, and and where it released or trespassed into the building. And so when under ordinary circumstances where you don't have a hurricane, right, or a tsunami or a tornado, curtain walls and sliding windows and outswing doors and so forth, you can expect that you will have most of the water uh, not enter your building. The majority of the water should just sort of run on the surface and be expelled at the bottom. But during hurricanes, there's a number of factors that occur, and there, when you've had a testing background like John and I have, you kind of know that there are sort of behaviors that you can expect that are anticipated because of how these systems were engineered and designed to withstand successive loads at a very successive very high pressures, and that there's going to be certain movements and dynamic movements of windows and walls that are that a glazing system should be able to do and keep the water mostly out of your building, and not fail because of any kind of fatigue or permanent stress or anything of that nature, which oftentimes novice sort of consultants will come in and say, "Oh, there's fatigue." There's no fatigue. These systems are designed to withstand major impacts of major pressures, and should stand up very well. You may have some leaks, but during a tornado or tsunami or something, but it doesn't necessarily mean that the structures fail. So we spend a great deal of time trying to sort of um, understand, what are those performances that a curtain wall or window wall or sliding door or what have you should behave and act. What's the performance you would expect? Um, and so you would expect, that at least the water issue during normal conditions, during ordinary conditions, during normal rains, you wouldn't have a problem. Air infiltration, that's another performance criteria that's becoming ever so more important because of energy conservation issues. Um, and then structural. And the rules are changing as we speak on some of this stuff. But for the most part, those are the big three in South Florida that we spend a lot of time analyzing.
And John, I think you really hit the nail on the head. Was one of the hardest things for folks to understand is that all those performance ratings are different. So think about a window or a door, especially a door. We want to be able to see through it. We want to be able to walk through it. We want it to keep outside out and inside in. We're asking a lot. You're asking a whole lot, right? And so when you look at it from a manufacturer standpoint, if we were going to make a door, for example, or a window, it's a lot easier to make something that's strong enough to keep outside out wind or even a 2x4 that's blown around. It's a lot more difficult to keep the small stuff like water and air out. And that's why when you look at the performance ratings, traditionally, the air and water ratings, water in particular, is about 15 to 20% that of the structural rating. So you can see the dilemma, right? Now we've set ourselves up for failure. We've set ourselves
Right.
up for something that is otherwise undamaged, but it leaked. And when people see a leak, it's really hard for them to associate that leak with something that's not damaged.
Right.
And that's the fundamental challenge.
That was excellent how you put that. It's like the complexity of life, right? You have you have sin where it's this notion of the this potential thing that is really really good, but then it's sort of connected to something bad, right?
Right.
Water, right? It's this idea that there's these in the same space you could have good and bad, right? Oh, a curtain wall that lets you do all of this stuff, but by the way, every so often you may get a little bit of water through an assembly because you had a terrible, terrible storm. And I like to remind everybody, I've been going through hurricanes since 1963, 64, category 5 storms. And everybody can expect power outages, right? Entire neighborhoods, communities, no electricity for days. But God forbid you get a little bit of water now, and it is unsurmountable. And to tell people and to explain to people that, listen, you could have electrical outages, but you can't have a little bit of water in your window assembly in your penthouse on the 40th story of of a tall building. That's not a fair equivalency, that the two things, that you if you're going to be, they should be equivalent to a certain degree. If you're not going to have, electricity, you could expect a little bit of water, especially during a hurricane. Um, and I don't know about you all, but I've enjoyed every hurricane I've been through since I was a kid. And I've seen all the potential damages that are associated to hurricanes, from glass piercing through, um, another piece of glass without blowing it out, to metal being dented, and glass acting almost as a spear into aluminum foils of, at tops of tall buildings. The extraordinary things that happen in hurricanes, and to think that a little bit of water could be so damaging as sometimes it's reported. In reality, it's inconsequential in the big picture of things.
Yeah,
Right.
John, and you're absolutely right. I mean, when you look, I've seen statistics somewhere around 80% of post-construction dollars to fix buildings has to do with some amount of water leakage into it. And so, you know, part of this discussion today is about career pathing, right? And that, John and I have had somewhat of a blessed, career path and so forth. But one of the things that you've heard the expression follow the money, right? When you're picking a career path, it's important to follow the money. And when there's money that somebody has to spend to fix something after they've already built that something, when there's money that's in dispute because between a carrier and an insured, then there's opportunity for consulting, right? Whether it's engineering or architecture or testing or anything, there's opportunity there to help solve that dispute or that risk. And part of the career path is to be able to recognize where the bigger opportunities are.
Right, right. And especially in South Florida here, we're basically a battleground for and a testing ground with all the hurricanes that we face. And that kind of helps us to segue to the other topic that we were talking about, which was insurance, right? And it definitely is a big issue for here in South Florida. So, John, I wanted to know from your experience, how has it been navigating the challenges in the insurance landscape?
Yeah, I mean it's been fascinating, and I do think you're right. I think Florida is kind of at the tip of the spear. Um, and it's you just look at some of the recent history, right? There was a point in time where there was AOBs. They've since been legislated out, as I understand it. There was also, a recent change in attorney fees and so forth. There's also, as most folks know, there was, very few providers that withstood some of the more recent storms, and so a lot of people, I think it was up to like almost 50% had citizens, which is essentially, government insurance at this point. Um, and so, you see all of these things happening to Florida because, yes, Florida had a lot of substantial claims in the last 10, 15 years. And well, what you could see is, there was a lot of learnings that were done, right? On the legal side, on the contracting side, on the adjusting side. Um, and the insurance side. And it's not about good and bad in terms of a side, but when you look at it, there was big dollars at stake. There were people that have suffered. There's insurance carriers that have been out of business. And I would say overall, the process is challenged, right? But again, when it comes to engineering, when it comes to other consulting type of opportunities, there are more opportunities now for engineers and forensic architects than there were 10, 15 years ago because the exposure is more, the risk is more, and in some cases, the industry is somewhat broken, right? Um, do I think that this will spread to other areas, maybe out toward Texas and even up as far as New York? I do. I think that what we've experienced and lived through in Florida is coming to a state near you.
Yeah,
Right.
I think I would tell you that the when thinking about career paths in for folks up and coming, um, and probably drawing some of my own personal experience. I was fortunate to have as a kind of a mentor certain people that either directly or indirectly were involved in the forensics of developing the best type of glazing assemblies throughout the country for at least several years as a test engineer at the construction research laboratory. And so there were many fathers at this laboratory that were senior people when I was young, that I would witness how they would go about developing product lines for their manufacturers. There was a time where there was a firm here in Florida which was state of the art as a wet sealed system, which was Glassaloom. And at Glassaloom there was Emil Scher, and Emil and his team would test at the laboratory, and I would watch him as a senior expert in manufacturing work out all the bugs from his curtain wall system, right? And having been the test engineer and watching the performance of his systems pass the first time all of the water tests, the air infiltration tests, and so forth, I realized that there was a process that was very clear how to wind up with an excellent product. In the same vein, as a young man, I was able to see all of those that pretended, or I'm not going to use the word pretended, but tried very hard to formulate a procedure to make sure that their assemblies worked at the laboratory when when they would test to get a AMA ratings, national AMA ratings, and they weren't so successful. So by a process of contrasting the very good experts at the time as a young man and watching them, and then the very poor or not so good. Now I'm not going to use poor, but they would try very hard, and watching why they failed, I was able to come up with my own process of elimination as to when I find problems and defects and so forth, because I witnessed the entire range from really good experts to not so good experts, right? And so I think being connected to someone like John Runkle, and his team, or certain certain people out there that have been around this industry for 20, 30, 40 years, and watching their process becomes very important for that young kind of graduate that is really intrigued with material science and the building exterior envelope, right?
Yeah, John, you bring up a great point because, the job that you're doing today was not the job that you did 20 years ago. And I do see a lot of ambition in this next generation. Um, and it's funny coming from me because I probably have less patience than the average person. In fact, I know I do. What I don't see is a lot of patience, right?
Yeah.
And you have to, I believe you have to get that experience, and it should be an eclectic experience, because if you've worked in a lab, if you've worked as a contractor, if you've worked as an architect, as an engineer, as a designer, and you've put on multiple hats, so to speak, within this construction industry, it will give you a better chance at being a good forensic engineer and a good forensic architect, because now you have a different perspective, right?
Right.
And you've have a different skill set that you've picked up by learning from other folks, because it's a lot more fun to learn from someone else than it is by learning from your mistakes. which is a far too common way for us to learn these days.
I think that John, one of the things that John, and John's a little younger than I am. I'm not gonna admit my age, but I think that what I learned from John is how humble he is, and getting and appreciating somebody's methodology or system, and saying, you know what, that's actually a pretty good idea, right? And giving credit for a good idea, as I've done with John. I think it's a two-way street there. It's like,
Yeah.
it's great to have another expert that you could say, hey, let me bounce some ideas off of you. What do you think? And then kind of getting a different perspective that you can trust, that is not advocacy, because sometimes we find ourselves competing against advocates, that no matter what you have to say that's scientific, there's always this sort of contrarian out there that says, well, yeah, but I have another approach to that. Well, you know what? If you haven't been around for 20 or 30 years and seen how it's been done by the last 100 people that tried, then maybe you should stop and listen, because you might actually learn a thing or two. And I think that there is ambition. Perhaps it's a generational thing. When I was younger, I'm pretty sure that I kept my mouth shut because I was going to get, for the most part, browbeat to death, or I would get the stink eye from all the senior classmen in the room, right? And I didn't like that feeling. I think that the sort of generational moments now that I see folks perhaps talking out of turn on significant claims, and the level of experience doesn't match the degree of problem that these folks are advocating for. And I say the word advocating in a way that I understand. Attorneys have to advocate for their clients, but experts have to speak from the standpoint of science, a scientific method, an approach that's above board, that is based on pathologies, and from the standpoint of developing a hypothesis and proving the hypothesis one way or another, and being honest enough to admit when the hypothesis turned out to be something else, that your hypothesis wasn't what you expected it to be, but it turned into something else that now you can explore, right? And that's part of that process of arriving at facts and not conjecture. And I think that one thing that I try to do is, as I develop a theory, that I can prove the theory one way or another, and be able to say, I proved this. I can show you how you can prove it too. It's traceable. It's factual enough that someone else can trace it. And I think that that's how John and I sort of met, in that I put together a set of facts. I said, this is how I arrived at my facts. And John, I think that by you testing my facts, either it's going to be, you're going to be able to prove that I'm right or wrong. And it was great, because it was an independent sort of fact-finding mission. That, is it traceable, yes or no? And I think that for young people, that's the process of elimination sometimes, in sort of figuring out what a problem is. Maybe there's no problem at all. It just happens to be wear and tear, and there's no problem. And so that's how the generation that comes behind us in this field has to look at things, not from the standpoint of advocacy, but as an unbiased expert that can prove yes or no the source pathway of a leak, or the damages discovered during an inspection.
And both of you made interesting points about the approach and the process in which you operate, and it speaks to balancing that left and right brain thinking, right? Having that technical precision, but at the same time having creative problem solving. and you both expressed that very well in how you've managed to use that in balance, right, in your careers. What advice would you give young professionals to be able to kind of balance those two sides of thinking?
Well, I'll tell you, my advice would be to hang out with Mr. Medina for a little bit. And I would say that was the thing that really struck me when John and I first met, was that he really had a mastery of the art and the science. And few folks do. And I'll give you a couple examples. You know, it's one thing to have the right science and the right answers and the right physics. It's a whole nother thing to now communicate that to somebody that doesn't understand what you're
Right.
trying to talk about. And John can do that in many, many ways. You know, I mean, he's a master at, you know, demonstrating things visually, you know, from his drawings to the way that he understands how people think. And I think most engineers um, underestimate the importance of the art within our practice, and could learn a lot from hanging out with Mr. Medina, in my opinion.
That's very kind of you, John. You know, one of the things that as an expert, in order to call yourself an expert, all right. And I'm going to tell you that I think John's an expert. All right. I don't have to put adjectives as to what degree of expert. He's an engineer. That sets him aside as an expert because of his degree, a licensed engineer. And then in addition to that, he has that niche knowledge of testing that very few are invited to be part of. And he managed hundreds of people in inspections, in testing, in laboratories, in one of the finest outfits that, in my opinion, that, you know, and I know the background of where John comes from, but one of the finer laboratories, you know, here in Florida and other places in the country. Right. So he was invited to be in that group in order to test and make difficult decisions one way or the other on how products work. Right. I luckily had that invitation as well. I seized on the opportunity to be part of that because I really truly enjoyed it. There's great satisfaction in not only developing new products but figuring out what goes wrong with new products,
Right.
and not only in the laboratory but in the field. Sometimes the product worked fine in the laboratory, but field conditions change things, and you have to make them work in the field. And so, what I think John and I both have is how you fix it. Okay, how many people, you included, Daniel, all you listeners, you know, all of you and us can find and see water leakage or air. We could feel air going through a door. All right.
Right.
The magic isn't discovering that. Our own kids can figure that out. It's how you fix it, right? How you make it work in a reasonable way, especially in a world that people talk about resiliency and recycling and reusing and you name it. Which by the way, I've always been a fan of. Right? I think that when there's a will, there's a way, and you can make things new again. At least I think of myself that way, that I can make myself new by doing exercise every day. So I truly believe that you can take something that's old, but it doesn't necessarily mean that you can't it doesn't have life in it. And now anybody could take something apart and say, okay, you know, let's just put in a new one. And I think the world that we're going into is no, let's do the very best we can to salvage what we have, make it work. And you know what? If it shows a little bit of this you know, of the dents and damages that life brings us, hey, we all age, and you know, there's beauty in things that are older. You know, at least I believe so. So, I think that we have to find the way to fix things, and that's what makes an expert. An
Right.
expert in the field of the exterior envelope is not only that you can test it, it's not only that you can specify it, it's how do you fix it? Or how do you change it? How do you change it out? And that's when you can actually don that hat and say, okay, this is the right direction. Unfortunately, the new kids on the block will oftentimes go straight to, you have to remove and replace the entire thing and start fresh. And whatever that costs, it doesn't matter to me because I'm not paying for it. The insurance company's paying for it. And that's not being your brother's keeper. Your brother's
Mm,
keeper is protect society, take care of your fellow man, make sure that everybody's safe. And by the way, don't be disrespectful to the resources we have in place. You
Right.
can't to exchange something for the sake of exchanging it because someone's going to make more money from doing that versus fixing something. That's not right. And so we spend a lot of time trying to bring into the conversation those things that have been practiced for 40, 50, 60 years before the issue of insurance and water infiltration damage became a thing in Florida. Right? How do you take care of something that ultimately you may have to replace the gaskets, replace the seals, keep the frames, replace a broken light of glass every so often when a ball hits the glass from a kid that throws a ball or a BB gun or what have you, and shoots out a light of glass. How do you replace that and make sure that system continues to work as it was intended to work? They're old Model T cars that still operate, right? Nobody junked those cars. They're old Porsches and old cars that cost hundreds of thousands of dollars that are older. You change out the gaskets. Gaskets dry out, right? And I
Right.
think that the notion that you can salvage assemblies and you don't have to change out the assemblies completely, and you can work with them over time, that's to be expected. That's
mm.
not that's not the exception. That should be the rule.
Yeah, John, I think you nailed it. I think, a lot of times the easy solution is replace it. Um, but that's not always the only solution, nor the best solution. But I want to touch on something that you mentioned a few times. And so, when I did start, and I worked for Intertech Architectural Testing for 18 years, when I made that move from California back to Pennsylvania, and it's probably the largest lab for testing building enclosures in the world, I think. I made that move because I married a Pennsylvania girl and I wanted to raise kids, right? This wasn't a career move. When If you would have asked me at the time, this was for something. I was a consultant and I was happy to be a consultant. I was now joining a lab that quite frankly didn't want a consultancy within the lab. And it was an odd marriage, right? It really was. And it was what I didn't see, because I wasn't smart enough to realize it, is it was a career move. But it was really hard to see that, because you're too close to it, right?
Mhm.
um, you fast forward, and there's a couple of themes here. One is, if something's doesn't seem like a logical fit, you might be onto something. Two is, if your boss asks you to do something that you wouldn't typically like to do, it might be better for you if you actually do it. And I'll give you another example with that. There's several professional organizations that I've been heavily involved with. Back in the time when it was still called AMA, I was involved with AMA, and my boss said, "Hey, John, they're developing this standard for testing existing windows and doors, meaning something that's been installed for 6 months or longer. And I'd like you to, take an active role in helping them write this standard or guideline." I didn't want anything to do with it. I'll be honest with you. It was busy work. I'm an engineer. I like dealing with numbers more than words. You fast forward, it was the best thing that could have happened to me, um, but I didn't see it at the time, right? And then jump forward maybe 5 years after that. and there was this new practice that came out called building enclosure commissioning. And um, commissioning had been around for about 10 years, but it was mostly MEP type things. And what you saw is this new practice that was all about building performance. And you can't identify building performance without functional performance testing, which is the commissioning way of just saying testing, right? And so here I was by happenstance in the world's biggest lab with consulting background and a growing consultancy at the same time that building enclosure commissioning came to be a legitimate profession in the United States. And so, all of these things were, I would say, more dumb luck than anything else. Now, I recognized a few opportunities when they hit me in the face. But what I'm saying is the important thing is just because something doesn't seem completely logical, if you are gaining experience, gaining a different perspective, doing something left brain, right brain, working with people that you can learn from instead of having to learn from your mistakes, you're going to be on the right track. And if your boss tells you to do something that you don't want to do, it might be good for you.
Right. And on that same vein of making these tough choices, John, Medina, you mentioned in our last call, sometimes you're in a position where you really have to make a tough choice, especially when you're confronted with, testing a project or red flagging it. Obviously that there's a lot of financial stakes involved with that. What would you tell people that are starting their careers, or that might be faced with this moment down the road? How do you navigate those situations?
That's a curious question. I like the question because it brings me back to a time in my career where I was a professor at the University of Miami, and I was all of like, I'm going to tell you, 27 years old, 26, 27 years old, and I was all full of myself because I was the chair of the technology department in the School of Architecture at the University of Miami, and I had a secondary appointment in the School of Engineering, and I had these great bow ties that I would wear to work every day, and I felt I had arrived, and I remember talking to a visiting faculty member that I had brought to give a series of lectures from Germany. I can't tell you the fellow's name. He was probably 5 or 6 years older than me, and I went to dinner with him one day, and we started talking about some esoteric theory or concept in engineering and architecture. He was a very technology oriented designer, as I am as a design architect. I could always draw very beautifully and design beautiful things, but I was always intrigued by the technical parts. And I don't know how the conversation moved towards me giving like this very senior type uh, opinion, as if I had been around for 50 years. And he very lovingly and very delicately caught that moment and said, John, you don't have to have an opinion right now on everything. You don't. You know what? You just relax about that. Just take it all in, and one day it'll all mature in your brain, and you're going to be okay. And then you can make those. But right now, maybe you don't have to go so far. And I turned around, I looked at the fella, and he made me kind of give a double, that kind of double glance and say, "Wow," and it took my breath away. And I'll say that over the years, I've known my place. I've known my place, and even though I had the role for a long time as a faculty member, a senior kind of position where I was teaching in both the School of Engineering and School of Architecture, I just kind of was able to sort of make fun of myself a little bit and think, well, you know what? Maybe I got to do a whole lot more research before I talk so boldly, right? Took me a very, it took me years and years and years to sort of feel comfortable where I could make those difficult calls and decisions and not second guess myself. And I'll say that now at being in the senior class of my career, that I recognize how serious um, some of the questions I have to give a position on, that and what it can affect to either side. And I take everything at that level because I can, because I understand it that way. But when I was younger, and I tell a lot of people in my office, I said, you know what, I don't expect you to be expert right now. Just be an inspector. Learn how to be an inspector first, and inspect, and then learn how to kind of attend meetings and take notes and copy things and just and read and do the research and kind of be a research assistant, and then start tying things together with some testing. And before you know it, 20 years have gone by. Now you could really give some opinions that matter, right? But you don't have to do that in the first few years. You got to learn from others. And I agree with you, John, 1,000%. When your boss tells you to go look at something, and or do something, go do it. Don't complain. Don't be don't resist. Usually there's a learning lesson in that effort. Yeah, I'll admit that there are a lot of times that I don't want to go out in 100-degree weather and sit in a testing laboratory that was made out of steel with the sun facing right into the glass, and doing a water test for 15 minutes. It was like being swimming in a sauna, outdoors, right? I admit that there was a lot of those type of moments, but there was no better way to learn how a system was supposed to perform unless you were in that sweat box watching whether or not the window or the door or whatever it was, the hopper, the casement, um, you know, performed as expected or not. And there's a lot of those moments where I could think specifically, John, to your point, is like when my boss at the time, which was Dick Cimbello at Construction Research, said, "I want you to spend 2 or 3 weeks caulking with the caulkers outside." And I'm like, "You mean to tell me I got to get dirty?" That was my reaction, right? And sure enough, for 2 or 3 weeks, I was going in every day and saying, do I need to keep doing this? Have I learned my lesson yet? There's no way you could talk about caulking if you haven't caulked before.
Right.
Right. And when I hear people talk about caulking from a book, and they've never really applied the technology themselves, it's kind of hard to believe that they know what they're talking about, right? And so I think that that eclectic notion that John brings up, I agree. Learn all these lessons while you're young, because they're going to come in handy when you're older.
Yeah, and I think one of the difficult things is, you know, gaining those experiences and still, there's a larger and larger drive to have this balance between work and life. And I would say, if you could criticize probably John and certainly myself, you know, maybe a little too much dedication to work over the years, right? But when you do that, when you really pour yourself into work, when you're passionate about it, when you say yes to the travel, you do get an accelerated learning. Yeah, I've been fortunate to work, probably in 30 different countries, I would think, just about every state in the US, several Canadian provinces. Um, you get to see a different perspective. You get to have a different experience. And the reality is, you get to learn more because of that. You're not seeing the same thing over and over again. Um, And it's hard because you want to make that sports event, or you want to spend time with your family, or you want to have uh, that set schedule that you can count on, and do those things. But I would encourage you to, from a career perspective, to fight that urge to kind of have business as normal, to get out of your comfort zone, to travel, and get out from behind the computer. We live in an age now where you can get a ton of information online. You can get all the information probably that you ever want online, but don't misunderstand that for experience.
That's great. Today I was talking to someone that 20 years ago I went to. This is a kind of little war story, John. I think you'll appreciate it. We were uh, a big builder in South Florida took me out to see a project where there was an issue associated to a some pitting of the paint and at the extrusions at some sills and near some gaskets, along some gaskets. And the conversation about what was the fitting or the appropriate uh, 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 composition of the gasket, what it should be. And that was about 20 some years ago. And we did the research back then. We kind of came up with what we thought the problem was, and we gave it an answer. Over the course of 20, 25 years, we continue to do research on the product. I don't want to mention any names because it's been given the product was given a bad name for a number of different reasons, and one of them was the manufacture of the product in other countries that we don't know what procedure they use to make the products. And in the long run, we kind of realized that just you can't judge every book by its cover, by the same cover. The product works in gasketing in cars and the lunar rover, missiles, all sorts of places, windows and so forth. So just because there's a bad batch and the batch, kind of for a while damaged some paint, it doesn't mean that always happens. And so it was a conversation that we could, both the contractor and I, the representative of the construction company, we both could take it to the moment when we remembered what had happened 20, 25 years ago. And I was able to bring them to current time as to how those arguments didn't apply to all buildings using that component part as in the gasketing of windows and frames, right? So there's an enormous amount of learning that has to continue. Once you think you know something, you have to keep challenging it to know that you actually know what you know. I don't know if that makes any sense, but you have to challenge what you think you know, and you oftentimes realize that things change and the explanations change over time, and it's complicated, right? It's just simply complicated. And so an expert can understand that idea that you could have in the same space various things happening that are completely acceptable, completely acceptable. And then you take into it all the external stresses, the internal stresses, uh, uh, human nature, and that we're not perfect. And at the end of the day, you can come up with a reasonable answer. It's those moments where and I'm not going to say those moments, but for those younger people coming up in the field, it's really important to continue your sort of growth, knowing and learning as much as you can about products and assemblies and developing your skill sets.
So I think there's definitely been at least 50 years worth of experience in this last hour that we've shared. From the takeaways I've learned so far, it's been be patient, listen to wisdom, Take it all in. You don't need to give your opinion right now. Challenge what you think you know and get your hands dirty and think outside the box, right? Anything else you guys would like to share in terms of final thoughts on how we can encourage the next generation?
Yeah, I think John hit it, and it's okay to it actually is more than okay. It's the hardest thing is for once you've been anointed an expert is to say that you just don't know, right? And I see this happen especially when people they get into their maybe like a single shop where they're just a one person thing and they have a wonderful experience and everything, but they kind of stop learning at that point because they're not surrounded by other people who are giving them new perspectives and ideas. And I think it's important to always stay into that learning mode in your career.
Right.
And as an expert, just because someone has anointed you as such, to be comfortable by saying, I don't know when you don't know. It's okay. And, but say yes more than you say no. Try new things. Be uncomfortable. Surround yourself with talent.
Excellent. John, anything?
Yeah, I think that I echo that. That was excellent. What you just said, John. I agree. Just sometimes the right answers I just don't know. You know, I remember 30 years ago when I was or whatever when I was teaching that I had started and someone very wise said, sometimes a student you'll be challenged by a student and you'll realize that you thought you knew something and you in the moment you second guess yourself, and it's perfectly all right to say, that's a great question, and I'll get back to you because I don't have the answer right now. And in our field, where we are oftentimes challenged by thousands of pieces of information associated to one type of problem, you have to kind of sometimes regroup, have an opportunity to think about something and say, and then get back to it and say, okay, I got the answer. And I think so. I agree with John. Just saying I don't know is a very fair position. I think what is a very unfair position is when people don't know and correlate many little theories
Right.
and pretend that they have an answer. And it comes off that way if you're listening. But the resolute, the person that does have the factual evidence to make a decision based on science, they come off with specificity, with a degree of information that you recognize that there's iron in those words. And I think that as young people go through this notion of I don't know is fair. Just say it.
Mm-hmm.
Be comfortable in
Yeah.
your own skin. It doesn't make you any less smart, And I think that perhaps that's also a generational thing that people, you're expected that because you went to college, you're supposed to know. It doesn't work that way. You have to build that experience.
Well, gentlemen, if we have, I think that I think we've wrapped up a great episode. I think we've gotten a lot of valuable, serious career knowledge providing to young professionals. Uh, I want to thank you both. Thank you, John Runkle, for joining us today.
Yeah, thank you for the opportunity, John and team, and it's been great, and I really enjoyed it.
Yeah, it's
Excellent.
fun. Thank you, John. I appreciate it too.
And if anyone wants to catch the replay, make sure to head over to our YouTube channel. It'll be there later on this week. And don't forget to follow us on LinkedIn to stay updated. And we'll see you next month on the next episode of Behind the Curtain Wall on the last Tuesday of the month. See you all. Thank you, everyone.